Are you down for a trig identity challenge? If so, here's one for you. We are going to simplify sine square x over 1 plus cotangent x plus cosine square x over 1 plus tangent x. And I would like to tell you, this right here is equal to 1 minus 1 half sine of 2x. Usually, I will put this kind of questions as a multiple choice with 4 or 5 choices, so we will know if we have to keep going or we can stop. I don't really like to say verify this is equal to that because you have the answer right in front of you, and secondly, people will just do some random work and all of a sudden equals that. But anyways though, I will show you guys all the steps going from here to here, and it involves so much. Have a look. My strategy is, let's work with sine and cosine only. So here, this is sine square x over 1 plus. We see cotangent, we don't like that. Change that into cosine x over sine x. Now for this one, we have cosine square x, which is good, over 1 plus tangent is sine x over cosine x. Alright? Now, for this one, we get a complex fraction, meaning we have a small fraction instead of a big one, but it's an easy fix because we can just multiply the bottom by this denominator and do the same on the top. Likewise for this, I will multiply the bottom by cosine x and then multiply the same thing on the top. So this is equal to that, which is equal to this now. On the top, we have sine to the third power x. Distribute this to that, so we have sine x. This and that cancel, so plus cosine x. Continue, we add. The top is cosine third power x over cosine of x, and then plus sine of x. Now have a look. The denominators, they're actually the same. The order of addition doesn't matter. So now we can actually put them together. Earlier we couldn't do so because the denominators are different. Otherwise, I know sine square x plus cosine square would have been so nice because they are equal to 1. But here we actually end up with a third power, right? Unfortunately. Anyways though, here we have sine third power x plus cosine third power x over, let me just write this down. We have sine x plus cosine x. Now we have to be careful. We cannot just cancel because they have a plus in between, right? To legitimately cancel this out, we will have to factor the sum of 2 cubes. And let me remind you guys the formula right here. So note, something's cube, so a cube plus something else cube. This is equal to a plus b. If this is a plus, the first term right here is also a plus. And then next, we will have a square minus, right? A square and then minus, and then a times b. Lastly, we add b squared. So here, sine x is our a, cosine x is our b. So for the top, if we factor it, we will end up sine x plus cosine of x. You are using this formula here. And then the next one is a square, which is just sine square. I'm just going to write it down here. Sine square, like this, minus a times b, which is just sine x times cosine x. And then lastly, plus cosine square, because that's b squared. So cosine square that x, like this. And then on the bottom, something is nice, huh? Sine x plus cosine x. This and that cancel out completely, which is quite nice, right? Now I'm going to just do like this. So for now, we will have sine square, and then I'm going to put this right here, right after that. So this is plus this part, which is cosine square x, and then minus sine x cosine x. Now have a look. What's the first term? Finally, we get to add sine square and cosine square together. They are just going to be equal to 1. Now how about this though? We have the minus, sure thing, but sine x times cosine x, what is it? Well, this right here should remind you of the double angle identity. I'll write this down right here. If we have sine of 2 theta, angle whatever angle is, this is equal to 2 times sine of theta. Sorry, 2 sine of theta and then times cosine of theta. Now we have this part, theta is dx. We don't have the 2 though, but it's okay. We can divide the 2 to both sides. So for this portion, we can say that's 1/2 sine of x.